Rusty Oliver. We're at Hazard Factory, standing in front of the Combat Robotics Armor Test Enclosure, working on the delivery system that we're using to deliver a payload of up to 250 pounds. That's the weight of most of the battle bots fighting. And the idea is to set this underneath our payload and then push it with a large pneumatic cylinder.
Go.
So last week we found that the pneumatic system that we cobbled together out of parts in the shop was underfeeding a little bit. We wanted more pressure, we wanted a more regular delivery system. Particularly, we wanted to be able to operate it remotely because we can't be inside this area when the weapon is moving. So we have a storage tank, plenum. We have some gauges on the inbound side so that we can verify what we're actually delivering to the plenum. And then we have a simple two-way solenoid switch, which is going to be operated off of an Arduino. So from last week to this week, this is the change that we've made. This is the former valve, and what we figured out was that the restrictions inside this valve were a little bit much for our system. We've replaced it with a beefier valve that has much larger openings, much less restriction here. We were originally thinking that it might be this T-fitting, but once we checked the specs, it was actually the internal workings of this valve that were restricting our flow somewhat. So we have our sled at 48.8 pounds and our carrier plate at 86 pounds. Then we have 6 individual weight plates at 22.8 pounds, yielding 222.8 pounds total. This tank is cut. That satisfying clank. Once we have the armor that we're testing and some blocking that's set up here to simulate some shock absorption take-up, we're going to be very close to the 250-pound payload. We've made adjustments here at the cylinder. Now we can send this object with increasing or decreasing pressure so that we land at roughly the delivery rate that we want. We're all set to go. We're at 35 PSI and firing. We're running at 40 PSI and firing. We're delivering at 45 PSI and firing. And all clear?
Clear.
At 50 PSI and firing. We're mounting a piece of polycarbonate in front of the second camera, the one that's going to be looking sort of downrange, so to speak. This is a 1.25" Lexan, so I've personally shot at it with 30 caliber machine guns and they don't go through. We're pretty conservative with how much material we're using to insulate this environment, so I feel pretty confident. And we'll know soon enough. In Greek mythology, Sisyphus was actually the cleverest of mortals and was punished with the task of rolling a boulder uphill and being crushed by it every day. So Matt's been doing programming, which is really similar, and as an act of catharsis, we're going to feed the Dell server into our Tomb clone.
So we're going to sacrifice one of the old servers that has given me nothing but grief over its lifetime. So it will get paid back for all of the pain and agony it caused me. The plastic, I think we proved, is not good armor. This has some metal, probably still not good armor. It is very heavy, so we think maybe 25-30 pounds. We are going to check to make sure it doesn't have batteries.
All right, we have the pneumatic system set and tested. We have a server loaded onto our in-feed device. So we are now ready to feed a server into the Tomb clone blade. We'll be looking at the tachometer to see if the blade slows down at all, and we'll be looking at the debris for exit velocity, just to see how hard it takes. We're all ready to go. Fire when ready. Like a corner hit right here.
Wow.
This whole grill, I bet then it spun around and caught it a second time.
Wow.
Look at this little bit.
Oh, nice. You see the shrapnel stuck in it.
So that had some velocity when it hit. We're on our second test now. We've loaded a microwave with ping pong balls, and the idea is to simulate Brownie in motion. Most of the ping pong ball occupants seem to have survived. Yeah. Self-polishing. What? Oh, we left the spinner in. Oh my God. It's stuck right here. This is embedded in the wood. It's totally jammed in there. I can't get it out by hand.
Wow. Here, I kind of cleaned this off.